In today's video we're going to look at the equation of a circle. The aim is that by the end of the session you can match a circle up with its equation. To begin with, we're going to start with a circle that's centred at the origin. The origin is the point 0, 0, it's where your two axes meet, and x and y are just coordinates on that circle. R is your radius, so that's the length from the centre to the edge of the circle. So if you pause the video and copy this down onto your worksheet, this is the equation of a circle centred at the origin with radius r. To help us see what's going on, we're going to use www.desmos.com, which is a fantastic graphing package that's free to use. So if you want to try and get that on your phones, there's a great app on there. It just helps you visualise what's going on. So we're going to have a go at example 1 on the sheet. So I've typed in x squared plus y squared equals 9. And what you can see is we've got a circle centred at the origin, and you can see that the radius is of length 3. So to help you, I've put the equation from example 1 beneath the general equation, and hopefully you can see that where r squared is, you've got the number 9. So we're looking for a number that when we square it, so in other words times it by itself, we get 9. And so that would give us 3. 3 times 3 is 9. So that tells me that I've got a circle centred at the origin with radius 3. So we can pause the video and you can have a go at sketching that circle on your axes on your worksheet. The general equation for any circle is given in this form. What you can see that's different now is instead of just an x squared, I've got x minus h all squared, and then I've got y minus k all squared. And what these values h and k are, you can see they're the coordinates of the centre of the circle. R is still the radius, and that's still in the form r squared. So in this video we're not going to go through the proof of where this equation comes from, but for an extension task, if you want to go away, there are plenty of videos on YouTube that go through this. So now again we're going to use Desmos to help graph some of these equations and see what they look like. So I'm just going to type in the equation we've got there for example 2. Once I finish typing that in, you should see that it's no longer centred around the origin. So if you look at the equation and look back to your general solution, you should be able to see that the coordinates of the centre of that circle would be 2 and 3, and it would have a radius of 4. Alright, to help make that a bit clearer, I've laid out the equation next to the general solution. Where the h was, there's now a 2, so that gives me the x coordinate of the centre. Where the k was, there's now a 3, so that's the y coordinate of the centre. That gives me the centre of coordinate 2, 3. The 16 on the end, so we're looking for what number times by itself gives me 16, so that would be a radius of 4. Now example 3 is slightly different again. If you look, it's got x plus 1. If it was x minus 1, the x coordinate of that centre would be 1. So if it's x plus 1, it's telling me the x coordinate of the centre of that circle is actually minus 1. The y coordinate would be 4. And it would have a radius of 5, because 5 squared is 25. So for the final time, pause the video and complete example 3. It might feel like that we've rushed through that and you're not really sure what's going on. You've got your notes that you've taken now, and what I'd urge you to do is to use Desmos on your phones, so you can enter those equations and see what appears. So your task now is to either complete the matching card activity or, for a tougher challenge, the teddy bear task.